Hi, today I will be explaining about power amplifier. Power amplifier are divided to three classes. The first one is class A power amplifier, second one is class B power amplifier, and the third one is class AB power amplifier. I will focusing to the class B power amplifier. Class B power amplifier are operated by two transistors, which is NPN and PNP. This is a block diagram of the class B power amplifier. The operation for the class B power amplifier. Class B operation is provided when the DC bias is left, the transistor bias just off. The transistor turning on when the AC signal is applied. This is essentially no bias and the transistor conduct current for only one half of the signal cycle. Moving to the next slide. To obtain output for the full cycle of signal, it is necessary to use two transistors and have each conduct of a half cycle. This circuit is referred to as a push-pull circuit. One part of the circuit push is signal high during one half cycle, and the other part pulls the signal low during the other half cycle. The comparison for class A and class B power amplifier. In class B, it using two transistors to provide high efficiency. In class A, only using one transistor provide low efficiency. Second one is in class B provide high power transmit to the load, while in class A provides low power transmit to the load. And the last one is class B dissipated only small amount of power, but in class A dissipated in bigger amount of power. In the class B power amplifier have two type of the configuration. The first one is transformer coupling, and the second one is two complementary symmetry transistor. I will focusing to the two complementary symmetry transistor. This is a configuration for the two complementary symmetry transistor. The operation of the two complementary symmetry transistor. The NPN transistor provide the positive half cycle of the AC signal across the load. Then the other PNP transistor provide the negative half cycle of the AC signal across the load. The disadvantage of this configuration is needs two separate DC voltage supply. Then provide crossover distortion in output signal. So thank you.
Hi, hello, my name is Tenmoli Munyandi. I'm from 2B EKGS1. In this video, I'm going to explain on circuit design and calculations for question 2. Let's see the circuit design of this question. This circuit is called as Class B amplifier. Class B amplifier contains of two transistors. Those are one NPN transistor and another one is PNP transistor. This other elements of this circuit is RL and Vin. Vin value for this circuit is 10 voltage peak, and the VCC value is 10 volt and negative VCC is negative 10 volt. The RL value for this circuit is 10 ohm and the I is equals to 1 ampere. Now let's move to the calculation of this question. In this question, we have to find power and efficiency of the circuit. Let's list down the importance value of the element. RL is equals to 10 ohm, VCC is equals to VL because this is the maximum efficiency circuit. VL is equals to 10 volt and the IL is count in peak, so the value is 1 ampere. Let's find the value of VL peak using the values that we know. Let's use the formula IL is equals to VL over RL. So let's insert the values into this formula. So from this we will get VL is equals to 10 volt. As we know, VL is equals to VCC, so the value is 10 volt. To calculate the maximum power input, the formula that we are going to use is power in DC is equals to VCC times with 2 over pi times with IL in peak. Insert the values into the formula, so we will get 6.37 volt. For maximum power out, we are going to use the formula VL square over 2RL. 10 square over 2RL is equals to 5 volt. To find the efficiency of the circuit, the formula that we are going to use is P out over Pi times by 100. So 5 over 6.37 times by 100 is equals to 7.85. To find maximum power dissipated, the formula that we are going to use is maximum of 2 power dissipated over 2. So 0.25 times V 2 VCC squared over pi squared times by RL is equals to 1.01 volt.
Hello, now we are proceed to the circuit simulation. We are using PSpice to build this Class B power amplifier circuit. As you can see, we are using 10 volt of AC supply, 10 volt of VCC, and 10 ohm of RL. This is the voltage input 9.97 volt. I will press the marker to the output. And we will get the output current is 892 milliampere and 8.9279 volt of output voltage. Then I will place this current marker to this transistor and simulate. This is the waveform of IE. We add plot and place this current marker to this transistor, and we will get the IC waveform.
At the end of this study, we are able to investigate the operation of the power amplifier in Class B. By referring the notes given in lecture, we verify the answer based on question given. From the simulation result, Class B operation is provided when the DC bias leave the transistor bias just off. The transistor turn on when the AC signal is applied. This is essentially no bias, and the transistor conduct current for only one half of the signal cycle when it is turned on. So, to obtain output for the full cycle of signal, it is necessary to use two transistors and have each conduct on opposite half cycle. The use of two transistors make the Class B power amplifier provide greater efficiency compared to one transistor. Finally, more power can be transmitted to load and eventually increase the efficiency, and the transistor dissipate only small amount of power.